Okay, hello. My name is Lise Singh. I'm a professor in the Computer Science Department and a research professor at the Massive Data Institute. I'd like to start by welcoming all of you to Georgetown and to this beautiful bioethics research library. It's one of the nice venues here at Georgetown. Today's event, Data Blending, Tackling the Obstacles, is sponsored by the Massive Data Institute in the School of Public Policy. So this event is part of a larger scale effort at MDI to think about innovative ways to answer research questions by combining or blending both traditional and new forms of data. More organic data, where the original intent of the data and the data generation process differ from the questions that the data are being used to help answer. So while the increase in the volume of data available might seem like a panacea for researchers, these new forms of administrative data, as well as social media data, have generated challenges around data quality, representativeness and validity, concerns regarding consent, and issues around the lack of universal data standards and common data taxonomies. Today's discussion will give us an opportunity to get a range of perspectives on these issues from academia, corporate and government officials, and researchers. So we've designed the event to be in two distinct parts. The first part is a panel discussion where scholars will share case studies and possible solutions for different challenges. Here we'll see more of a focus on organic data sets that are generated from social media sites. The second part of the event will be a conversation that highlights different data blending projects that are being undertaken in government agencies. Here, the focus will be more on other types of organic and administrative data. Our hope is that the ideas and directions that are shared today can help us develop a set of best practices for undertaking different types of large and new data blending projects. So let's get started. Let me introduce Jonathan Ladd. He's an associate professor in the School of Public Policy and in the Government Department at Georgetown University. He's also a non-resident senior fellow at the Brookings Institute and serves on the executive council of the Elections, Public Opinion, and Voting Behavior sections of the American Political Science Association. And he's written extensively on public opinion, polarization, and media distrust, including a book entitled Why Americans Hate the Media and How It Matters. Dr. Ladd will be the moderator of the data blending research panel. So come on up, and maybe we can also have all the panelists come up at the same time.
Thank you. Thank you for a very nice and overly generous introduction. I appreciate that. We have a really great panel to start off the program this afternoon. I'll start off with introducing our wonderful panelists here, and I'll introduce them in the order they're going to speak. The procedure we're going to follow is they're going to speak for about 5 to 7 minutes, and then I'll ask a few questions to start discussion, and then we'll have questions from the audience. So our first speaker is going to be Quinn Nguyen, who is an assistant professor of epidemiology and biostatistics in the School of Public Health at the University of Maryland, College Park. Her PhD is in epidemiology from the UNC Gillen School of Global Public Health, and her specialization is in social epidemiology. I'm very happy to have her here. And after that, we're going to have Josh Pasek is going to speak. He is an associate professor of communication studies and a faculty associate at the Center for Political Studies at the University of Michigan, part of our wonderful group of Michigan guests here today, and as well as he's a core faculty member of the Institute for, as MIDAS, Michigan Institute for Data Science, and his PhD is in communication from Stanford. After that, we're going to have Zaina Mnemne, who is going to speak to us. She is also one of our Michigan guests. She is an assistant research scientist at the Survey Research Center at the University of Michigan, She has her PhD in survey methodology from the University of Michigan and involved in a ton of other projects, including she's the director of the World Mental Health Data Collection Coordination Center, and she's the chair of the Executive Committee for the International Comparative Survey Design Initiative. And finally, we're going to finish it off with, he told me just to call him Goha. I wanted to, so I'm just going to do that. Just Guha. He is the creator of widely used web standards such as RSS, RDF, and schema.org. He's also responsible for products such as Google Custom Search. He's also a co-founder of opinions.com and Alpiri. And until recently, he was a Google Fellow and a Vice President in Research at Google. He has his PhD in computer science from Stanford, so he's going to be our fourth speaker. Very excited for all the speakers. I will now hand it over to Quinn, who will talk first. Good. Are they on the laptop? Let's see if they're on the laptop. Okay, they're right here. Here we go. Great.
And let's see if I can project into the mic. Okay, thank you so much for the invitation. I'm very happy to be here. So I'm going to be trying to cover a lot. So we've been working on this for we're into our 5th year. As a social epidemiologist, the motivation for doing this work is to try to get contextual variables that beyond social demographic characteristics available from the census, and trying to predict health outcomes. So what we're interested in is what are some area level characteristics that are related to health outcomes, and I'll show you some of the characteristics that we derive from Twitter. So one project, this is the newest one actually, is trying to look at sentiment and racial attitudes using Twitter data. And we, to kind of get like a data set of potentially race-related tweets, we built about 500 different race terms, like a list of 500 race terms, some of them including just normal race categories used by government agencies, and then others include like racial terms. So from that, we were able to collect about 2 million geotagged tweets, and then an additional 31 million that are, they're not geotagged, but they have place characteristics. So these tweets come with like a bounding box and a text description, but the bounding box we found is basically the size of a state. So for those place characteristics, the smallest area is the state level. And we'll show you how we link it to health. So on these tweets, we implement sentiment analysis, and we're finding to use training data. We use training data from other groups as well as providing training data from our own group, and we're finding quite satisfactory levels of accuracy, around 90%, F1 score around 84. So we're quite happy with the sentiment analysis. A caveat is that comparing geotag versus non-geotag tweets, we see very different patterns. So I'm sorry if it looks kind of small. This is by state. So if we're looking at prevalence of negative race-related tweets, we kind of see for a lot of patterns, a lot of states, it looks like it's increasing. But if you restrict it to geotag tweets, a lot of the states look like they have decreasing prevalence of negative tweets. So not same patterns at all. Geotag tweets make a very small proportion of tweets because they're an opt-in feature. So on your phone, you have to turn on location and also enable certain settings in your Twitter profile. So it's a multi-step, and it's not like it's opt-in rather than by default. So we have about 5% of people or less geotagging their tweets, and hence the representation is going to be a concern, and selection bias definitely can influence the results. So this is a map of just using tweets with at least state level characteristics. So it's a map of some states having more negative race-related sentiment, at least according to tweets. So you see darker blue means more negative sentiment. So kind of the South and part of the East Coast. And so why does that matter? What's interesting about characterizing race attitudes? And so one of our initial cuts is to look at birth outcomes, because pregnancy is a very defined period, and birth outcomes can be influenced by stress. And so we're finding that states with very high negative sentiment, for instance, have an increased risk of low birth, very low birth, and preterm birth. And what was surprising is that we see this in the full population as well as when we're restricting to minorities. So initially we thought we were only going to see this light up for minorities because they are, potentially the top, like the target of race-related tweets that are about minorities. But it seems to be elevating adverse outcomes for the population. And so when we're looking across subgroups, we also looked among non-Hispanic whites, and we also continue to see adverse associations between more race-related hostility and more adverse birth outcomes. And this is using vital statistics. So we love the Twitter data is one thing, but then to relate it to health outcomes, we need other data. So the health outcomes comes from the 2015 natality file, and it has characteristics like maternal age, whether mom smoked, education status, body mass index, prenatal care. So controlling for all of that, as well as state level characteristics like state expenditures on welfare, race composition, median household income. So controlling for that, we see a slight increase in adverse outcomes. We've also looked at CVD outcomes. So places with more happy tweets seem to have lower hypertension, stroke, MI, CHD, and conversely, states with more sad tweets have increased risk of these outcomes. We derive other measures from Twitter. For instance, happiness, so just the overall sentiment of tweets for all tweets, general tweets. And then tweets that mention physical activity, tweets that mention food, and then the characteristics around food like caloric density, whether it's fast food or healthy food. And before going into this, we had these characteristics a priori. We didn't know whether it would relate to any health outcomes. And controlling for census characteristics, including population density, percent white, median age, median household income. We're seeing that so areas that are happier, that mention physical activity, that mention healthy foods, those are related to lower chronic conditions. And we're using NHANES data, which the strict version has the zip code. And so these are individual level data, with Twitter being the area level predictor. And that's kind of a snapshot of the kind of work we're doing.
All right. All right, so you guys might not know this, but there's this funny thing that a blender company did where they sort of had this Willet blend on various different devices, and it felt quite fitting to use for thinking about data blending. So this is an iPhone that somebody was blending in one of those commercials. What I'm going to do is present sort of a little bit more on a theoretical level here, trying to think about when it is that some of these techniques to try to bring various forms of data together might work and when they might not, right? And so if you want to start that activity and you're like me, sort of a survey methodologist in my training and other stuff, you start off by thinking about where we are in our current paradigm, right? And our traditional paradigm for understanding things about society and for understanding relations between things in society is survey research, right? And that paradigm involves trying to understand attitudes and behaviors by asking carefully constructed questions of a sample of people that are carefully designed and selected to represent the public as a whole, right? And so, the trope is that they call you up and annoy you during dinner to be able to successfully do this. But there are a variety of challenges that have plagued surveys in particular in the last number of years, and that response rates have been declining. It's not unusual right now in a lot of reasonably high quality but non-federal surveys to have response rates as low as 5 or 6%. The costs are increasing even to keep the rates at around that. And coverage challenges are becoming increasingly problematic, right? You now need to figure out how to combine landlines and cell phones. You need to do a whole bunch of things like that to make a reasonably representative survey. And so it's increasingly difficult for those reasons to translate from respondents as a whole to the population, right? That you're making a variety of assumptions when you're doing so. Right, and so this raises a question of under what conditions might you be able to use other kinds of data, right, to either complement or supplant traditional survey research and come to many of the same inferences that we've had from those kinds of data. And I'm going to talk very briefly, but I've done work sort of in 3 different areas of this. One is just using non-probability surveys to do some of this work. Another is looking at consumer file marketing data, so the stuff you can purchase from companies to try to find out about people. And the third is using social media data. So I've done various different projects using all of these, and I'm happy to talk more about my thoughts on any of them. But if you want to think about the different kinds of insights that you might get, right, on an individual level at least, right, if you're thinking about sort of adding to what we know about individuals in surveys, well, there's information that you can get about the respondents from various kinds of supplemental data, right? There's information you could get about potential respondents, so maybe about the people you don't reach in a survey that might be able to tell you about who else was in your sampling frame or who you tried to reach and systematically what individuals you were able to or not able to get, right? And you're able to get a bunch of additional data about the specific people who respond as well. Right? There's also various kinds of insights that you could expect to get on an aggregate level from these kinds of data to differing degrees. So you might be able to find out things about populations if you have a good additional source of data, even if you don't necessarily have a probability sample, right? So you might be able to tell the distribution of some particular aspect in society. You might be able to think about sort of other forms of data that might let you test large-scale social hypotheses, or you might be able to actually measure changes over time, even if you can't necessarily get exactly an accurate point estimate on various things. But the real concern here is that our ability to make inferences from novel forms of data, whatever they may be, right, depend on how well we understand the sample that we're getting and the process that's actually generating the data. And this presents a series of theoretical and empirical challenges that we have to get around if we want to use these data for any sort of substantive purposes in addition to traditional surveys. Right? So if we think about when alternative data sources are going to be valuable, well, we need to think about, for instance, who's providing the data and under what circumstances. So if you think about something like social media data, those data are being provided by people that are making a decision to actively post about a particular subject at a particular time. It's a very different process from having your attitude on a particular matter elicited through the use of a targeted question to you, right? People might never happen to talk about some issue that we care about, or might only talk about it when it's in the news or other things like that, which is going to lead to very different circumstances when something's going to come up. The data themselves are often quite different in nature. That ranges from things like who they describe to what exactly is happening there. And there are a variety of practical, ethical, and analytic differences that you need to deal with how those data are being used, right? It's not ethically the same thing to be, scraping data from somebody's cell phone as it is to be looking at data that people have given explicit consent to providing, right? What I've found across a bunch of different data sources that I've put next to surveys in terms of doing this is that there are often a bunch of gaps. So for instance, with consumer file marketing data, when you purchase data from these companies, what you end up finding is there are some big issues with accuracy, the extent to which the data exists for certain individuals versus other individuals is highly variant, so there are huge missingness issues, and the data cover very unusual groups of people. And so you can end up with circumstances where you find, yes, you know a whole lot about people who own their home and almost nothing about who actually rents their home, even though those are technically separate categories of the same variable, which seems nonsensical until you realize that home renters don't fill out warranty forms to the same frequency, and thus their data's missing, right? With regard to social media data, typically it's common to find that you can create individual linkages with social media data for about 40% of respondents. Pew did much better in their recent thing, and I only just heard about this. But a lot of people don't post on topics of interest. So when I've been looking for, posting about, political topics, for instance, you end up finding that most people don't end up talking about it. And in fact, in the small set of data that I was able to link, Democrats talked about Republicans and Democrats more than Republicans talked about either one. And so your baseline initial assumptions about what you are measuring can often be wrong. And those individual posting tendencies vary by types of individual, which can create a whole bunch of problems, right? If you think about non-probability sample survey data, here you're moving to the aggregate level, right? Can you make the same overarching inferences? What we've found across many studies is that for distributions of variables, you're going to be off by an enormous amount a lot of the time. Relations between variables do better, but still aren't perfect. And there are huge differences when it comes to trends over time. Right, with social media data, distributions of variables are a disaster. We don't know how to calibrate social media metrics to tell you about population parameters. We have discovered some serious problems with coming up with things like trends over time in ways that would mirror what we end up getting off of surveys. The only thing where I've found we seem to be getting a decent grasp is if you want to identify something that you could sort of later use a survey to track, like trying to figure out what events are happening, right? You can find that stuff and then plug it into a survey or something of that like, but that makes a lot more sense, I'm going to argue, in this regard. So my argument then is that so far most of the techniques provide very different answers to questions than surveys would. Core questions about data quality and representativeness sort of need to be answered and often aren't answered in blending exercises. And if we want to think about where there's utility here, we need to really look at those narrow cases where we seem to be getting some leverage. So things like identifying events, understanding relations between variables when the data actually provides an ability to do so, and thinking about sort of when the ancillary data are high enough quality that we can actually use them to supplement at the individual level. Thank you.
I was going to say, Lisa said that the next speaker is much taller. I think there was a little bit of measurement error there. Not too much, but a little bit. I know, but John is not the only one talking. Okay, so let me see if I can blow this up, because I don't usually use Mac. So how do you slideshow? Play from start. Okay, good afternoon, everyone. First, I'd like to thank Lisa and her group for organizing a much-needed meeting. We're all kind of like struggling with the same issue of how do we blend data, and a bunch of us are doing very similar things that I think it would be nice to come in one room and at least talk about some of the issues that we're all facing. I'm very pleased to be here, and I'll specifically be talking about some of the research finding that we have been doing as part of our collaboration between the Massive Data Institute in Georgetown here and Michigan. So we have a group of researchers, Josh is one of them, and there's many of us here. We are doing joint work trying to really try to understand more about data blending. And I think all of us, are barely scratching the surface. We really don't have much understanding yet, and we're trying to, get a little bit insight of what that means. I'm going to specifically zoom into one specific type of blending. I'm going to be talking about micro data blending, which is when you have a survey data call record and you're trying to basically link it to a Twitter account by taking consent from the respondent. Josh has talked a little bit about it, and he mentioned the 40% consent rate. I'll talk more about what we know in general consent rates are and what predicts some of this consent rates. So I don't really need to go through all of this slide in detail because I think Josh has covered many of it, but basically, we all know that social media data is available, and I say available because some of it is more available than others, right? And if you look at the recent report published by Pew, the rates are increasing over time, though there has been relatively stable in the past few years. So since 2016, most of the penetration of social media has been stable, and you could see the rates here. Now, though they are available and though some of them we can explore, we really don't know much about our properties. Exactly what Josh said. We really don't know much about, I would say more specifically, we don't know much about their measurement property or the data generation process, because we really know about who they represent. And because of all the research that Pew has been doing and others, we know that they are not representative of the US population. There's definitely socio-demographic differences in terms of comparing US population to Twitter population. So I think when I think of data blending, I think of it as a tool to understand that data generation and the property before I jump into, we can blend it or not. I think of it, what kind of things we could do to understand the properties of a data first. Then we'd say, okay, good. Now that we understand it, yes, we can blend it. And I think what we will really figure out is like what we know, what we've seen in many of our survey research projects, it's very contextual. It might work for some, it might not work for others. There's so many different variables and situations where if it doesn't replicate in one situation, it doesn't mean that it doesn't, work for others. But we definitely need a lot more research to be able to figure when does it replicate, if at all. And if it doesn't, then that's not great. So when I think of also data blending, one thing that comes to mind is also whether we can use one source of data to validate the predictions from another source, right? So when we blend two data sources, we all know, for example, that Twitter, you don't have a lot of socio-demographic characteristic attached to it. Most user, whether it's geocoded data or other things, most of this information is missing. So by being able to blend and attach data to it, we can at least try to see whether we could predict some of those socio-demographic characteristics so that we can do more on group differences by using only Twitter data. And many people have done it. We are getting good accuracies, relatively speaking, on gender and age if you're doing large bins, but we're really not there even yet in terms of getting other predictions, getting higher accuracy on other predictions. Also, when I think of it, I think of, trying at least to see whether combining multiple data sources, you can gain more predictive power to understand an outcome. And there was a recent paper that has just been published by Murphy and his colleagues about whether Twitter data, you could predict, by using Twitter and survey data, you could predict sentiments toward using e-cigarettes. And they found, that adding Twitter data above and beyond the survey data improves their prediction of attitudes toward e-cigarettes. So this is an example that works. That doesn't mean it's going to work everywhere, but maybe one example that we could see some success to some extent. Okay, and then we can also think about it whether, can we collect data in different combination of data in different waves, especially if we have panel data, right? So you could think maybe I do survey data, collect survey data in wave 1 and wave 2, survey and Twitter data or social media data in wave 1 and wave 3, and in between maybe I can reduce the cost and only do one of the sources of data with the aim of maybe using one source to maybe impute or know a little bit in between waves about respondents, assuming there is some correlation between the data, which is still to be figured out. So, but for us to be able to do many of those things, one type of linkage is the micro linkage. Can I get consent to link? And some people say, why do we link if the data is available for public? There's many reasons why we need to consent. One of them is many users don't read the terms of service. We are basically predicting beyond and above. We're predicting information about the user more than they are sharing, explicitly sharing. I can predict their gender even if they don't know their gender. And so on and so forth. I really, because I have 2 minutes left, I want to go into the meat of it, and I want to talk about what we found in terms of what predicts consent, right? So maybe let me talk a little bit about, do we have any existing framework of consent for social media? We do not. There hasn't been any comprehensive frameworks that says what affects consent rates, what are predictors of consent. We have a lot more on administrative linkage, and some of the issues apply to social media, some of it don't apply. including, for example, the survey design feature. There's new papers published by people from Britain that says, well, definitely mode affect consent, right? Like if you try to get consent to link to Twitter data on face-to-face, you get that 40% rate that Josh said. If you're doing it on the web, you're getting much lower, anywhere between 20 to 30%. The panel that was mentioned, the JFK panel, the one that just published by Pew, it is on a panelist. They got 90% consent rate, but it's on a very different group of population. We have to keep in mind the different populations that we're talking about. Okay, let me jump about 2 case studies that we've done quickly. The first case study is a web survey that we conducted in collaboration with researchers from Belgium. It's a among college students web survey on mental health. We asked them if we can get their Twitter handles, and we got what we usually see, 24% consent rate when you are asking on the web, right? So this survey wasn't designed to link Twitter data. It was designed for another purpose. They added those questions for us. But what we were able to do is we were able to add questions on the frequency of use. So what we found is that the more social network sites you use and the more frequently you use Twitter, you're more likely to consent. We think it's the relevance issue, which we've seen later. If it's relevant to you, you're going to consent more. It didn't seem that the type of use of Twitter matters, whether you read or retweet or just don't report any use. It's not related to consent. We also find something interesting here, which is the more you report symptoms of alcohol use, the more likely you consent. Now, I don't think it's related to alcohol, of course, not because you're drunk, you're consenting, but it mainly because both of them are correlated with third variable, probably, that you just report sensitive information. You don't really worry about much privacy when you're reporting. So there's a third construct there that is, affecting that relationship. The second case study is from a national address-based sample of the US. It's a mail to web, not web to mail. Sorry, there's a typo there. Mail to web. We mailed these link, and then the responding clicked on a web and on the URL and went to do the survey. Again, we found same thing, about 27% consented. In this one, we didn't have frequency of use measure. It was basically a survey also on health, but it has a bunch of other factors. It has a scale that looked at helping behavior, whether respondents are more likely to engage in a helping behavior, such as I gave money to a stranger, or I helped somebody find a job. And we found that there's a marginal correlation between helping behavior and consent, which has been reported in the literature with other type of linkages too. We found that there's some association with religious identification. If you identify as a Jewish, you're less likely to consent. If you are more spiritual, you're more likely to consent. We still don't know the mechanism. It could be, you're more you trust people more. We really have not yet dug deep into the mechanism of those effects. And if you identify as a Hispanic, you're more likely to consent. And then what we wanted to look at, other than all of those social demographic characteristic and frequency of use that predict consent that I showed you, we wanted to look whether consenter and non-consenters differ on health outcomes, right? So all of those surveys the 2 surveys are heavily asking about health outcomes. And basically what this graph is showing you, and these are the variables or the health outcomes that we got from the address-based sample. These are from the college survey. And what really shows you is consenters and non-consenters seem to be the same on all of those health measures, which is a good thing to some extent, right? If you are interested in basically focusing on consenters, right? Now, but the big question remains, what did we find from their Twitter data? Was any of those measures associated? We have not looked at this yet. We just got IRB approval to get the handles. They were collected because we're using data that somebody else collected. So the next step for us is basically to look at what we gleaned from their tweets and to see whether there are any associations between some of those measures. We don't know. I mean, Josh and we all have our skepticism. Are we ever going to capture something on a smaller sample size that we can able to link to those specific outcomes? But we're also going to look at a bunch of other metadata and try to understand whether some of this metadata might be associated with some of those outcomes. I'm way beyond my time. I'm very sorry. Happy to talk about any of those aspects in the discussion. Thank you.
Hi, thank you for having me here. Wait, this thing is...
Low for you. Yeah.
Okay. We don't use PowerPoint where I come from. We have this thing called a browser, which is somewhere here. Nope. There we go. So I'm going to talk about this artifact that we're building called Data Commons. I work at Google. So just to set some truisms for context, data powers everything today. Science, journalism, health studies, everything. You're the last audience I need to make that point to. There's a ton of data, data.gov, DataMed, Dataverse, and the big ones, Census, BLS, CDC, FBI, NOAA, hundreds of thousands of files, CSV, different schemas. And the usage of using the data, the current model is a student, a researcher goes and forages for the data, tracks down the assumptions, pulls it down, cleans it up, compiles the sources, figures out where to store it, high upfront costs. The really interesting things show up when you start joining different data sources, and that is really expensive. They do this, they write their paper, the data goes away, the next person starts from scratch. The goal is to build what we think of as Google for data. Google is great because it allows us to pretend that the entire web is on a single site. What would Google for data mean? It's for use for programs. If you could enable a developer to pretend that enough, not all, but enough of the data that pertains to their domain is in a single database, single schema, single API, that would be good. The data model that we like is something we call a knowledge graph. It's an ancient data model from the world of knowledge representation in AI. It's basically that it says that the world is made of a set of entities with relations between them, and these entities have attributes. This is a simple fragment of a knowledge graph. It's about this musician, Tori Amos. It says that she's a musician. She is born in Newton, which is a city in North Carolina, and so on. This is an unremarkable fragment of a knowledge graph, except for the fact that different parts of it come from different sources. Now imagine having to write a piece of code that goes to these different sources one by one and puts this graph together for you, versus you just have a single API to navigate the graph. The long-term vision for Data Commons is, imagine if we could pull together all these data sources, everything from Census to BLS, FBI, NOAA, CDC, Landsat, Wikidata, EPA, a whole bunch more, growing bunch more, and that anybody could contribute to. And you integrate this into a giant knowledge graph. Of course, this thing becomes too big to download, so you get web APIs, so that it just goes. And we believe that if such a thing were to exist, it would be really, really useful. For starters, in many cases, you don't have to, it avoids a repeated data wrangling. You avoid the burden of data storage, indexing, etc. The biggest benefit is from joining, and the more you know about two references to an entity, the easier it becomes to join. If such a system were to exist, we think lots of people will use it. The problem is jump-starting this ecosystem. And this is exactly the kind of thing that Google is good at. So we've built a version 0.1. We've integrated large chunks of ACS, BLS, FBI, CDC, NOAA, and a whole bunch more stuff. Python, the core engine is open source, because we often get told by the academic community that you guys do something, then you lose interest, and then you move on. So we decided that what we would do is we take the core engine and make it open source. And we're working with both Stanford and Berkeley to create instances of this that they are running. There's two applications that I'll briefly show you to give you the idea of what it is. But before that, let me actually show you. You should be able to go to, can you read that? Is it too small? Let me make it a little bit bigger. Okay. Browser.datacommons.org. Everything I'm showing you today is public and open. I come from this amazing, beautiful city called Mountain View in California. This is a simple browser. It shows you a node at a time and all the arcs out of it. A bunch of details. You see we have USGS, Census, and let me actually show you the raw view. Census, FBI, BLS, CDC, and so on. It's a nicer view as a timeline view. This is population of Mountain View by gender, drill down. This is women in Mountain View, drill down further. This is Asian women in Mountain View, and so on and so forth. So we have all this data. What is it useful for? The first thing that we decided to do is to actually use it for students. According to edX, over the next few years, there's going to be something like 2.5 to 3 million students who are going to take data science courses. And many of these data science courses, they learn these methods and they then apply their tools on toy data sets. Here was a study that we did where the students built a model of obesity across 500 US cities as a function of blood pressure, unemployment, and people below the poverty level. This would be a multi-day or a multi-week exercise, just gathering all the data. To cut a long story short, this is BP versus obesity, this is unemployment versus obesity, this is poverty versus obesity, and then they go on to build complicated models. And the interesting thing from our perspective is that we had 400 students do this in Berkeley. It was the upper division data science course in under an hour for grade. And so if you bring, we believe, okay, then other application that we're doing is for data journalism. Wouldn't it be great if more journalism was actually based on fact? Some people say that the crime rate in border cities is going up. There's a bunch of variables about them. About El Paso, the thing that we're interested in is the violence. Doesn't seem to be going up. Maybe a different city because, no, I'm sure it's these crazy Californians. No, let's do this per capita. Certainly not. Journalist, can I get this chunk of data as the JavaScript code like you can embed maps? Sure. You want the raw data? Sure. You want to build your own interface like this for different kind of a thing? Sure. You want to go navigating around for interesting stories? Somebody discovered this thing, which is another beautiful city that these cities are really boring, but they're there. This is next to where we are. Not crime, but if you look at, there's literally thousands of variables here, by the way. But the thing which we're interested in right now is nativity. It's a very interesting thing happening in these Silicon Valley places. They crossed over. The number of native born is now less. And you'd say, wow, that's interesting. Maybe New York is like that, right? Melting pot and all that stuff. Nah, New York is not like that. And so what are the variables that correspond to this? This is a story. And what we're doing is we're giving this thing away so that every journalist can use it. And the only condition is that they put their the citation for where the data comes from, which is leading to other people. Like we're working with Raj Chetty's group at Harvard. They're putting their data in. Sean Reardon is putting his data in, which means that you get the ecosystem going. And when you put your data in, you get APIs. Everybody gets APIs for using this data. It's not just in this domain. We're also building these kind of the core critical mass nugget in epigenetics, in energy data, and a few other verticals. So would love to collaborate with you all. Thank you.
Okay, great. That was wonderful. Those are four great presentations. Can I start by throwing just one or two questions to the panel, and then we'll take questions from the audience? Let me see how much. Okay. Well, given the time we have, I'm going to take one question. I'm going to throw one question, then throw it out to the audience, so the audience has some time for questions. So my question is, could you talk a little bit about if there are challenges with consent procedures when combining different data sets? I know that's different from industry and academia, but the ethics of consent for people to use their data when they come from different sources. And I know that we have all the same kind of ethical obligations, but academic research, we have different procedures for consent than industry. And then the government does. And is it a challenge when you need to tell people their data is going to be merged with some other data they don't realize it's going to be merged with? is there a danger, which is I'm always worried about, that they'll be completely spooked by this notion that some data set they don't recall even being in, you remind them and then you tell them, actually this survey response or this other data set is actually going to be combined with this other thing, and why is that not scary for people? Or does this question not actually come up very much? So I'm happy to, anyone who wants to jump in on this.
So we're about to launch another survey where we ask for consent, and I just got an email from the IRB about all the modifications I need to make to the consent. So it's definitely, there's a lot of challenges that are, I'm going to specifically talk about social media, of course. It's going to depend on the source, but if I talk about one case study, which is the Twitter, I think the fact that you are connecting to his data that is already available, right? So when you get consent, you have previous information about the respondent. And then you can keep collecting information for as much as you want, right? So the consent procedures have to be, at least what we are being required to do, is to be very specific about, what is the data that we're collecting and the duration, how long we're going to keep collecting data from them. So it's not like a survey, you go and you ask the question, you collect it, and you're done. And if you want to go back again, your consent has to say that would you be willing to do the survey again if they are paneled, right? But with social media data, you can continuously keep collecting data on them, and you have to have a duration. So can you tell them, I'm going to keep tracking you for 10 years, 20 years, till you die, right? So you have to have a time frame. So there's the issue of, that the data is, ongoing, and that there's historical data that once you access it, your consent has to specify that if you are going to added. There's the issue of followers, the followers and followee, right? So you have a pair, which we knew about. If you look at the literature about the use of network, information about the network, it's useful. You can predict some information by getting information about the network. And it's a very powerful thing, whether in terms of predicting demographics or other kind of construct variables. And you need to tell them. You need to tell them that I am going to collect information about the followers, but does that mean they have to go get consent from the followers? What does that mean? We still don't know. Now recently we're dealing with all of those issues. The IRB is making us be very specific about what kind of certain constructed variables we're going to do. Are we adding this? Are we using this to predict their gender or race, right? So I think there's a lot of challenges to, understand what is the right type of consent where we are informing respondent, but as you said, not freaking them out, right? So you're seeing consent rate without being, the consent rate I've showed you, those were not very specific consent language. I can show them to you. They're more or less, generic, more or less, with some being more explicit about other. And we still get 24% consent or 27 or 40. So I don't know what would happen to the consent if we're gonna add a lot more to that, which I think we should, but where is that fine line? I don't know the answer to, but there is, I think, specific challenges to consent that at least we're dealing with.
Well, I'll just note this is just all rapidly changing, right? So when I started running studies in this domain, 8 years ago or something, the IRBs viewed all of this stuff as completely exempt, and all you had to do was ask people in the context of the survey, and that itself was viewed as exempt, right? And so this is changing from a regulatory level very quickly. It's changing from a public perception level in that people seem to be a little less willing under certain circumstances to give consent because there's more of a recognition of privacy. It varies hugely depending on what country you're doing things in, and so how you think about this, and especially if you're dealing with any of the European regulations, right, it's potentially a fairly different game, right? How you think about this is very context specific to an extent that we can't even assume it's going to be the same 4 or 5 years from now.
The way we kind of address issues of privacy and not freaking people out, especially for race-related terms. So we collect over long periods of time. So for all the papers that we release, we generally collect over a year's worth of data, and we summarize, for instance, for a zip code or a county or a tract, so that any one person's tweet is going to be buried among lots of people for a year, and then we connect that with individual health outcomes from other surveys. So in a way, we're trying to make it so that people are not identifiable, that it's more, we're going to capture the social environment and not one person is going to be identified. And when we publish, we don't publish single tweets, we kind of describe them in aggregation. So that's how we kind of pay attention to issues of privacy.
Hi, with the caveat that I have never actually conducted a study of the sort you guys have. When we do things, we run experiment on 0.1% of our users, which is significant. Wearing a completely different hat, the law and computer science are on a collision course. For the first 30, 40 years of computer science, law plus computer science meant intellectual property. Now you have a situation where exactly what does it mean to something to be for India to say this is what our national borders are, and what is, or whatever other rules, like what does the boundary mean, right? What is epsilon privacy in terms of law? What's a valid value for epsilon? How do you even explain this to a jury? There are so many of these issues which are going to be, just like First Amendment has its limits. You can't go into an airport and shout, some things. Are there similar limitations for, Raj Reddy has this incredible talk where he says, at what societal cost privacy? If you could eliminate human trafficking at some privacy cost, that is a decision. Who decides that? Is it individuals who decide that? Is it the government who decides that? Is it society who decides that? These are incredible base capabilities that we have as a society now because of this that have to be regulated, modulated, I don't know, by the same mechanisms with which today's laws were created. And I don't think that's going to happen from the political process in our current environment. It has to come from the academic environments. And so I'm a computer scientist by training, so I'm looking to you guys. So.
Well, that's a good opportunity to ask for questions from the audience. Yes.
Hi, I have 3 questions, short ones for 3 of the 4 panelists. The first speaker, is it on? Green light's on. Anyway, let me just get the 3 questions out and deal with the technology. The first question is, what you showed us in terms of your findings, they were all for geotag.
Oh, yes,
right?
yes.
So could you speak a little bit? I'm sure you've been thinking about the selectivity issue.
Yes.
The second question is, have you thought about that Hispanic effect? I'm an international migration demographer, so that just popped up as a big coefficient there compared to other things in your model. And then with respect to our Google expert here, is Google working on doing something similar outside the U.S. context, using data in other countries?
The plan is to do that later in this year. We decided rather than go shallow and broad, we would go very deep in one area. And frankly, looking at in terms of open data, the U.S. is about 2 orders of magnitude, okay, maybe 1 order of magnitude better than other countries. And when you have some tool like that, I'd much rather have, we had the foreign secretary equivalent of the country formerly known as the United Kingdom visiting us a few weeks ago, and they were like, how come our data is not there? And the idea is to basically say, here, make it available in this schema, in this format, and then get everything together.
To address the first question, we only started to look for comparison between geotag and non-geotag tweets, at least with the race variable. So with the race variable, we have some tweets having place characteristics, so it has like state level, and more people are captured in that. And we're actually finding robust relationships with adverse birth outcomes, so that seems to be in the non-geotag as well as geotag tweets, which we were surprised because, like you saw, the state level patterns were very different, but yet it's still lining up. And we think that overall, our work with Twitter, we're thinking, we look at it like Twitter is an imperfect data set. It does not represent everybody. Adding Q tags is just adding more selection bias to it, but at the same time, it gives us some information that is we're finding it relevant to predicting health outcomes. So even though the information is selected and not representative, it's still providing you enough that it can track with certain health outcomes.
So the question was about the Hispanic effect, right? And I think there is some, we haven't looked at it explicitly. Keep in mind that the consent, this study was not designed to look at predictors of consent, right? So so there could be different level of privacy concerns among this age group. Among this ethnic group, there could be other issues related to trustworthiness, that they are more trustworthy. They could be more socially active in terms of social media active. This one did not control for frequency of social media use. So we're hoping that in the next survey that we are going to do, where we are designing it to explore more of those effects, we might, if it replicates, we don't know if it will replicate. If it replicates, then we might be able to tease out some of those effects in the coming one. But honestly, with this one, we are very limited. I mean, we could think of potential reasons, but we are very limited to, in terms of what variables we can add in to see whether that effect goes away or not.
Great. Do we have any more questions? Yes.
The Google thing, is that the Google thing, is that mostly publicly available data sets that you're using, or is that there are some proprietary data sets that are, or is it possible that this framework could be used by collection of proprietary entities that?
So the data that is publicly available is all public data. The architecture is such that it allows, the model is, remember we used to have these transparencies before, all these fancy things where you could overlay one on top of the other, and if you align it just right, you get the right effect. That's exactly the idea. So it's like your intranet versus the extra whole web. Only the people inside the company can see the intranet. And so let me give you one simple example of where there's a news entity in Montana we're doing a pilot with, and I didn't know this, but it turns out that the suicide rate in Montana is very high. And they're trying to figure out what on earth could this correlate with. Now, they don't want to release their data that they have to everybody before they publish it, so they're overlaying this on top of all of this other data. Stanford is building datacommons.stanford.edu, where Mark Cullen and some of his folks are building a layer about Stanford proprietary data, which is accessible only to a very limited number of people who've been approved, who've been, whose names are in the IRB and things like that. So that there can be many instances of this. It's not just one.
Okay, I don't want to shortchange the second panel, so we'll do one more question, and then we'll move on to the second panel. Yes.
Thank you, and I'll keep this short. Also, a question for Ram here. So in terms of the browser.data commons that you showed, what is it HIPAA compliant? You mentioned a couple of health-related verticals, right? So you said epigenomics and others.
Yes.
So those of us who are building data commons with health data, what can we use from this infrastructure?
So the epigenomics data is basically ENCODE. And so we're importing the ENCODE project with some people from the ENCODE this thing and putting it in. So for the health data, so given that we're doing this as Google, we have to be 10,000% sure that there is no privacy violation even remotely there. So everything that is public comes from, and that is run on the data commons from us. You can't, nobody can upload it. You have to put it out there publicly, and then we will suck it up. So the ENCODE project is all public, and so it comes in. And the stuff that Mark Cullen and co will run, etc., they are running it. It's theirs. All our data is at the base layer that comes into them, but then the layers, their own layer, they control, and if they run this, and it's their responsibility.
Well, please join me in thanking our wonderful first panel. Great.
Here today. In the center, we have Jeff Chen. He is currently the Chief Information Officer at the Bureau of Economic Analysis. Prior to that, he was the Department of Commerce's first chief data scientist and served several other roles in the last administration. And closest to me, we have Stephanie Lee Studs, who is the division chief at the Census Bureau for the Economic Indicators Division. She is currently responsible for 12 of the 13 principal economic indicators for the Census Bureau. She's been with the Bureau for 20 years and has a background in survey work, business architecture, and now 12 of the 13 economic indicators. So this is our group who's going to be discussing how data blending is occurring or should occur in the federal government.
Great. So this is better, yeah. Welcome. This group is really quite distinct from the prior panel, I think, on two dimensions. One, we want to drill into what's going on in the federal statistical system, mainly BEA and the Bureau of Economic Analysis and Census. But two, we'll be emphasizing economic statistics much more than demographic statistics. So there's a big contrast going on here. The wonderful thing about the characters in this room is that we can be as geeky as we want to be. I know you guys speak to wide audiences, but you can be as geeked out as you want. So welcome on that. And probably for this audience, the most important thing is to give us examples of real things that are going on. And I know both of you are dealing with different private sector data sources that are non-traditional to your agency. So Jeff, maybe you want to start.
At BEA, we produce the flagship indicator for GDP. And I want to start off by talking about blending in the prediction context, so focusing on Y hat. So we want to produce some prediction of some target series based on sampling signal, borrowing signal from a blended set of data. So the GDP number comes out as an advanced estimate and then followed by a second and third estimate that incorporates the information. But sometimes data that we need doesn't get to us until the second estimate. So that means this first number that comes out for GDP may miss some core signals, so then in order to pull that number through, we have to use a forecast. So the way we've been thinking about data blending in the prediction context is to look at as many different sources as possible to patch together a representative signal, something that would mimic the underlying trend in the economy. And so one area that we really need help on is the services sector. So about 46% of GDP is the services sector numbers. And we have basically underwent this whole machine learning algorithm development initiative to predict the services sector numbers. And we do this by patching together like monthly billable data from like employment and inflation indicators, as well as credit card transactions with mixed frequencies and mixed geography, as well as, and that credit card transaction data is actually pretty key because that's a data set that was made available to us through a partnership with the Census Bureau, and so thank you. And then there's also what kind of prediction project would there be without web traffic data from Google? And that's a weekly frequency. So together we're looking at about 1,000 indicators using machine learning techniques such as random forests to neural networks to produce an unsolvable prediction. And so what we find is that we can actually shave off about 1/3 of the revision on our predictions on GDP in key areas. So the health sector is about 1/8 of the GDP number. We can knock off about 33% of the revision just through prediction and using this data blended approach. There are some shortcomings to it, so it's a bit of a departure from the social science traditions where you have a structural model that you want to estimate and tell the story, but since we're focused on producing a prediction that will mimic economic activity, it's actually a pretty good application.
So you're predicting at the national level, at the moment of the release of the preliminary estimate, and you're actually predicting the first revision.
We're predicting the third.
The third revision, okay. And that's at the national level. But these data allow you to do other things as well.
Absolutely. We're using it for improved, well, actually, I don't want to take away your time.
No, you're good.
Well, go ahead. Why don't we switch to Stephanie's use of similar data?
So as Jeff had mentioned, we at Census came together with BEA to share some of these same data sets. Our business tactic was slightly different than what BEA was trying to accomplish. I couldn't have spoken better than some of the people in the first panel did, where they talked about survey respondents, the fatigue, the increase in cost, the reduction of response rates, things of that nature. So Census has really started an early engagement in really looking at these third-party data sets or alternative data sources to actually replace missing respondent data. And it's taken us a while to get there. So one of the core uses that we had, as Jeff was talking about, was we were able to use some of that data in seasonal adjustment in the ARIMA seats for some of our daily things, such as Super Bowl Sunday, Cyber Monday, things of that nature. It didn't work for us necessarily in the initial engagement to do some of the other things we really wanted to do, which was replace missing respondent data. And why is that so incredibly important to us? One, we want to make sure that we can continue to provide really good statistics, that gold standard that the Census Bureau is so well known for. But we're also getting a lot of questions and a lot of requests from our data user community to produce more timely, even faster than the monthly or the quarterly indicators that we put out. They want more product level detail. So in some of our engagements, what we've been able to find is how we can begin to produce additional products for our data stakeholders without actually having to add burden. So that's been one of the, I would say, true advantages to some of the relationships we've built with some of our groups. I would say transparency is critically important in this. So, and I can talk more about that later, but the transparency of the vendors and the groups of our alternative data sources has been critical. We want to understand, as I heard many of you say today, where is the data originating from? What is the original, where did it come from? What has been added to the data? Really any methodology that's been used behind it. So on a number of our groups that we're working with, the true success has been our partnerships with them, truly understanding the data, them understanding our business need, and then them being able to actually share how that data is delivered to them and what's been done to it in the process. Without that, I would say we've had some areas that haven't gone so well with these alternative data sources.
Mm-hmm. Jeff, why don't you say make some similar sort of comments about how you know what you're getting when you have the data. What have you done at BEA?
A lot of it is algorithmically driven, largely focused on figuring out if there are substantial biases in estimates. In particular, like one of the key things with any of these alternative sources is to tease out the signal of the actual company from the economy signal. So there's a lot of pre-processing and feature engineering that has to happen in order to weed out these odd signals. So in the case of this credit card transaction, is that there are large spikes in the raw series because these companies grow and contract over time. And so in order to level out the signal, we have to use some traditional survey techniques to have like a constant chain sample, but also incorporate other model-based approaches to smooth out the signal. And that's a common theme across all our work. Like we have another data set that we're looking at using rideshare. I can't tell the names specifically, but obviously you can make a guess.
An anonymous rideshare company.
An anonymous set of rideshare companies. The tricky thing with that data is.
So what are the data that you're getting from there?
Okay.
From them?
So we're trying to tease out if there's any bias in the economic estimates, because we might only get conventional taxis, but not rideshare in some data sources. So in order to bring this together, we have full population transactions for select U.S. cities for taxis, and then some cities actually get the total count of rideshare data, but then we don't have prices. So the prices we get from an email panel. So it's that some of these companies go out there and they offer services to the public, and then they get their email receipts and anonymize them and turn them into something that is matchable. So essentially, we're producing this. We have roughly a billion transactions across 3 U.S. cities in 3 years. We have 109,000 routes that are taken, and the time frequencies are all mixed. They're minute level, 5-minute level, 15-minute level, and they have to be matched into a way that would be usable. And so one way that we can make this useful is thinking about putting our sampling design hats on and developing weights that actually help level out the bumps in the underlying panel, the email panels, because otherwise we would get some really funky results.
Mm-hmm. Mm-hmm. So I assume the first time you looked at these data sets, you spent an inordinate amount of time in this pre-processing. Does it get better?
Absolutely. I mean, and then we had some code that was scalable to multiple cities in 4 weeks, and this was only 2 people's time, which is kind of nice.
You're just bragging.
So I would say we've had a much different approach. As I said earlier, we're actually looking to improve our non-response and reduce burden for our companies. So we've worked out and negotiated for that. In order for us to be able to do that replacement of data, we've done an awful lot of research with our 2012 economic census, with our annual surveys, with our monthly indicator surveys to say, does the data in fact look very much like what the company already gave us? And in many instances, we have found that it does match very, very well. So there's a complexity there that we feel comfortable in using that data. But in doing so, we found issues with their data sets as they found, or we have found some issues with our data sets as they gave us that data. So I would say it's been a much longer process for us. I would say we're still in the early stages. We've been at it for a couple of years. And anytime we embark on taking data that didn't come directly from our survey respondents, we're going to take that time to very clearly make sure that it emulates what a survey respondent would have given us. And in many instances, we're still working with them as we're getting these data feeds. So they're very aware we're getting them. They're part of the process, and we still do maintain those relationships and have discussions with those organizations.
So reflecting back on the data holders when you were first dealing with them, I'm sure we'd all be interested in what sort of cultural barriers did you encounter with regard to the rigor with which I know your agencies deal with data and how they viewed data. So what are the memorable stories that you have in your head with those kind of early conversations?
I think I'll just talk more generally about like the 2 distinct classes of data vendors, or actually really 3 distinct classes. There's one group that is in it to sell the data, and pure sales. There's a really small team that's working fast and loose, and they just want that sale out the door. There's another group that is a data aggregator that actually has a measurement science team. So they have these like really smart survey statisticians and physicists on the same team trying to figure out what the sampling weight should be, and they give you a full package. And then there's this other group which is typically more on the technology side, tech companies that are trying to throw their hat into the ring and get you to use some of their data, maybe to tell us part of the story of the economy that is not really being told right now. And each of those groups had very different reactions. First group, obviously, they want to get you a pilot, they want to throw a high price tag on, and they will give you a great business development engineering team, and then as soon as you sign the contract, they swap out the A team for the B team. Then the next team is the same team throughout the process, and the group that gave us we purchased the email receipt data from, they were just phenomenal. They have a great dedicated team, and they didn't even invoice us until we were completely confident that the data was good. But then, and then the last group, it's tough because the tech companies, some of them require the CEO of a big tech company to sign off on release of information, and then others, they just want press. They want to have publicity, and it's a lot of stop and go. It's really on their terms that the pace is not on their terms, not ours. And the data quality on the last group, they oftentimes will go and get contracts with the biggest and best economists and econometricians and publish in big journals to make the point that the data is good. So it's a very broad range.
Mm-hmm. Different stories. How about you, Stephanie?
So I would say the first group that Jeff was talking about is probably our joint relationship that we had. And I would say very much there was a lot of concern there because not a lot of transparency into how they produce their data, at least for what we needed, which was different than the solution that Jeff was looking for. So we very quickly, after numerous conversations, said, you know, we just don't see the value to us here. It was, okay, the data, we've looked at it, it just didn't give us the coverage. There was things that were missing that was solidified us and bring us that gold standard. And of course, they still want to continue to bring in the A team to sell you, and then same thing, we got the B team. The other organization that we're working with has hired data scientists actually to work with us. So they're an aggregator who has gotten data. I wouldn't say they're a huge company. They're probably a medium-sized organization who is working very closely with us. Like, they're very transparent in how they get the data. They've worked very closely with us. We gave them special sworn status at the Census Bureau so we could talk companies. We have a, I would say, three-way relationship. So between our companies, with them, with us. And that's truly proven to work very, very well. The transparency, the back and forth with the companies, it's giving us that good feeling that the data we're getting and how we're using it is headed in the right direction. We're also working on our construction indicator programs as well, working on building permit data. And you know, a lot of the building permit data is publicly available. However, there's so much characteristic data behind that some of these vendors have. It's been a unique opportunity to work with them because I don't feel as much the sales protocol, but really, truly, again, trying to understand the business need of the Census Bureau. And how they can help us. And what we found there isn't as much as we found in some of the others. That would take multiple vendors to actually service us to get all of those pieces. And we've worked real close with Jeff's team on Zillow data as well, working with them in the same respect. So we've had a lot of good opportunities. Some want to just give us data and let us work with it and work with us. And like I said, hire data scientists to really do that. And then you have to be wary of, I would say, the ones who swap the A and B team and who aren't very transparent in how they're doing business. Mm-hmm. And it's more of a sale to them and to say that they're working with statistical agencies in the government sector.
Mm-hmm. Mm-hmm. So I know when the federal statistical agencies first started talking about this, there were some concerns about losing control in the kind of way that Josh was talking about, how surveys are under design control, but you're losing that control when you move to these vendors. And one of the fears was that there would be breaks in time series that were actually undiagnosed by the firm producing the data. Have you yet encountered sort of a shock to a data series over time?
So I can speak to that while Jeff's thinking a little bit. So I would say from our perspective, we're, as I said, in the early stages, and we've only used a few companies for replacement of data. So no, I wouldn't say there's been any time series issues or any of that. I would say we've seen more of a fulfillment of more detailed data that we're actually getting that we weren't getting before. When we talk a little bit about like building permits and things of that nature, and again, protecting that, of which I'll speak to the indicators, we're really holding back that even if we went with one vendor, the most they can ever give us is like 30% of an industry. Or as I was saying, the building permits, we'd have different vendors providing us that data. We don't see in our interactions currently us losing that control. It's more of minimizing the cost and the burden to our respondents. That's really, what we're attempting to do if they're already providing it to these entities. But we have not seen the time series issues yet.
So I haven't been at BA long enough to see a break just yet. I've only been with the agency for about 18 months. But most of my work has been focused on the machine learning side of the house, so developing models that would predict. And these methods are constantly being retrained and recalibrated to adapt to the information environment. And we have controls in place to detect when there's a break. And so I don't have a story to tell you about the fears behind the breaks, but what I do have to say is that as we are getting into a more information-rich world, we should be looking at as many different series as possible, not necessarily to not only improve the accuracy of our estimates, but to actually robustify them. If we composite multiple series, multiple credit card transaction series, or multiple employment series, then we are getting more information that we can, in theory, produce a more stable signal. And we don't put too much bias and too much emphasis, too much leverage on one specific series. Like there's some forecasts that we put out, not forecasts, like they're short-range projections for the advanced estimate that are leveraging only a couple of indicators. And so if we're using more, many more, we're really diversifying that signal and making sure that we're producing a clean estimate.
Mm-hmm. So it seems like the two use cases you've emphasized are filling in gaps from non-response from a traditional design measurement process, and then you're using the advantage timeliness of another set of data to forecast out. The other uses that we all aspired to were those that were disaggregating estimates using finer grain data. And do you see that happening in your agencies in any way? So this would be, say, regional or state level GDPs using a blended estimate at that level. Are you playing with that sort of stuff?
So most of our estimates are actually blended already. So regionals county level GDP has blends of like employment data. There are data sets that are used for marketing research that are being used. And that there's a lot of trade journals and trade data sets that are being brought in to blend at different, and depending on the type of location, they will bring in different information. So there is a lot of blending that's being done. Are you thinking about it more in terms of like microdata level?
I'm thinking bringing in the private sector data to, in your terms, robustify the small area estimates in some way. It sounds like you're doing that. Your culture has already taken that step of using multiple data at lower levels of aggregation. What's happening at Census on that score?
So I'll use a couple of examples we're currently working on. So in the retail sector, more specifically, I would say we've had two things that have come out recently from the National Retail Federation and the International Council of Shopping Centers. So when we started to engage with these third parties, one of the core things we were looking at was being able to produce estimates at potentially a monthly segment at geographic levels. Well, once we got to working with the groups, they were like, actually what would be more beneficial to us with the changes in brick and mortar and e-commerce is more detail at the e-commerce level and more at the product level. So we very quickly, in about 4 to 6 months, put an agile group together to come up with the beginnings of a new e-commerce product that's going out as experimental. In what I mentioned earlier, where we're replacing some of the data from non-respondents, we are using that. And in the second case, we're looking to actually publish approximately 1,800 groups of what we have in NAICS and NAPs to what our vendor has at product level detail. So funny enough, we've been having like product day at the Census Bureau, trivet, spoon rest, you name it, we've talked about it. And so what we're currently doing is really working on using that data and refining that data to be able to provide our data user community on a much faster basis, detailed that they would typically only see in like the economic census. So we're really letting our data user community drive the needs and really what we're going after with these third-party vendors. So I would say that's two examples. And then with our building permits and construction, we're actually looking to potentially put out more characteristics at the lower geography levels that we can do with disclosure review.
So I'm interested in one other thing. There's another difference between this panel and the first panel in that you put out official statistics. People make real economic decisions on the indicators you put out. And so the care with which you move from the old method of doing something to a new official method has to be a careful transition. So I wonder if you could give us some insights into just how the culture inside the agencies are making those steps.
So right now we have multiple prediction efforts going on, and one way we kind of show off the new tech is to do a parallel horse race with current methods. And so we build the models, kind of treat them like, so this is going to be a Star Wars reference, but Luke Skywalker flying through the trenches of the Death Star with the little eyepiece. He doesn't actually use the eyepiece, so basically what these ML models are that eyepiece for people who want to use them. So essentially these things tell you, the prediction models tell you how likely are you to have a number in a certain range, and if that's going to be a large improvement, and why it's going to be a large improvement, what's the history of improvement, how likely are you to make that shot over and over again. And so essentially it's gotten a lot of great feedback and use. It's not an official part of the estimates, but it helps inform and guide our analysts in their research decisions. And that in turn gives us more capital to go off and get and explore new data sets and bring that into our estimates. We are looking at ways to make these official parts of the estimate, but I think the prevailing school of thought is that we should build more of these so we have competing models and see what our competing consensus models show.
Mm-hmm. Mm-hmm. Fascinating.
I would say for us, as I keep saying, we're in those early phases, and there is a lot of oversight to everything we're attempting to do. It's very much supported inside the Census Bureau. They see this as our future, and this is where we need to evolve to with data science and using alternative data sources. And again, we've been using administrative data sources for a number of years. Now we're looking to third-party, more of a commercialized front for these data sources. And I would say it's been really going backwards in time and using the data that we do have to our annuals, to our monthlies, to our censuses, and ensuring that they do follow the patterns. Having a lot of methodology oversight and review to everything we've done so far. And it's been slow. It's been a slow process, but we never want to engage in something very, very quickly that could change that gold standard of the statistics we release. And I would say the other piece is really helping us through the methodology concepts, how things are changing over time. And some of the things we noticed was in our methodology, when you get those lower level details or you're getting data from non-respondents in specific industries, what you're actually starting to see is maybe what the trends should have been closer to than what they were showing based on imputation. So there's a lot of things we're learning throughout this process, but we're very much supported inside the Census Bureau, and I would say very much from the community of people and businesses that we've been working with. I would just say we're moving with caution, just because we don't want to make those moves too quickly.
Mm-hmm. Mm-hmm. So that's an example of on the imputation where you're alerted to a process that we've been using for years and trusting and looking at it with new eyes.
Yes.
Yeah.
And how we may alter those methodologies or update them in the future.
Yeah.
So I think we see it as a lot of opportunity, and instead of rushing for one, it's really looking at it globally to say what other processes can we improve.
Mm-hmm. Mm-hmm. So you guys are pioneers in a real way, building a new paradigm, as was mentioned. earlier, and at any time in human endeavors like this, you learn things at a very, very rapid rate. So what are some of the surprise learnings or things that didn't work that you were convinced should have worked? And what are the things you now know that you wish you knew when you first started? Those kind of stories. What comes to mind?
I suppose one thing that we thought would be feasible to do is to predict every single indicator under the sun. With some degree of accuracy, because we were looking at some other research that some folks did and suggested that it was pretty feasible. But what we found out was, in order to produce a reliable prediction that would be useful to everyone, we have to come up with a measure of predictability. So it's some function of the overall error rate, as well as if it's a gift they'll keep on giving, meaning it'll slash revisions in every single quarter. And so when we apply these standards to our predictions, we find that only maybe 1/3 of the indicators that we're interested in are actually predictable. But the good thing is that for health, in the case of health again, health is 87% predictable, and we're able to slash about 1/3 of the error off of health, which is pretty nice. The other key thing was that coming from more of a pure stats background and working in an agency full of economists, we tend to talk past each other.
No.
So we eventually built a bridge. We have a vocabulary, common set of vocabulary now that allows us to communicate ideas that are not egregious in the other field, and it's been good.
I would say our funniest story at Census, I think, was how many of the entities that we've talked to, once they're inside the building, we actually had one yesterday, are actually using census data. It's pretty funny that their data sets include our data, and that what they really want to do is come into the building to get more interest in the data that we have and understanding how we're doing it versus what we're really looking for is, what data do you have? I think the other big thing we've learned is, we've jumped into a couple of pilots, and we did have what I would call a couple of failures. Like, we've really started to refine what we're looking for in our business needs and those kinds of things. And I would say the other piece that we've probably found in that is just building the partnership. I would say that has been the biggest thing to overcome, is just building that relationship with the vendors. Like, I think that's been our biggest win in all of this. Transparency.
This might be a good time to switch to there's a lot of food for thought in what you've said, so why don't we open it up to the audience for other questions or comments? Michael.
I have a question for Jeff. Yeah, thank you. That had to do with the forecasting that you're doing and your experience with it. In your experience, did you find that there were differences by domain in your ability to forecast? And by repeating the process, could you develop a sense of improvement by whatever measure you would use over time? Are you getting better at this?
Yes. So we purposely developed our ML methods so that they can be basically repurposed to any domain. But what we do find is that they tend to, because the following is going to be very intuitive, they do tend to be there tends to be poor accuracy in areas where the sampling error is large. So that's intuitive. Which is
That's a good thing.
That's a good thing, right? So like the theory works. And so that also, so now we know that when we're producing predictions, we should focus on areas where we have the smaller sampling. It reduces the total amount of cost that we have to put into cloud infrastructure to produce these models. We have a Bayesian spatial econometrician on staff who has been arguing that we should start to not only use the ML to produce the ML process, but then wrap it within a Bayesian framework, which would then help us get the uncertainties of the models. The tough thing is that some of our models, we run around 800,000 of iterations already. So if we put it into the Bayesian context with a Gibbs sampler, we probably need a bigger set of infrastructure to do that. But I'm sure that the uncertainties that we get from that would be quite telling for the economic estimation process, and would probably tell us if we can reproduce the same answers over and over again. But over time, we do see that there's a improvement in accuracy, but it might just be a matter of statistical power.
The unit at which you are getting the data from different vendors, they are pretty much different, right? Some of them are giving you at the county level, some of them state, some of them aggregated at the national level.
Some are national, some are state. The time frequencies will vary from daily to quarterly. So it's a wide range.
So are you synthesizing all of them into one particular
format?
Time and
one specific time, so national level, quarterly.
okay. So there's a potential possibility that you're losing some of those variations by not modeling at the different levels that they're giving you the data.
Yeah, so if we think about it in terms of like the sort of jagged edge and ragged edge problems for nowcasting, we definitely could do that, but at the moment we're sticking at the quarterly level, and we're trying to move away from doing single series models to kind of like a general economic algorithm for the entire economy.
So when you say single series, what do you mean?
So every single time series for like services sector estimate has a separate set of models. But now we're trying to get to a point where we can have one generalizable, internally consistent model that will rule them all.
And then you're also using the error rate, that how much revision that you're doing from the first to the second to the third, and in your forecasting that.
We don't incorporate that explicitly, but it's used as a way to rate the model. So we use, rather than using like cross-validation we use a cross-validation technique called M-blocks. So we basically produce a prediction for every single time period. And we use that, we put that through our GDP estimation process and get a revision estimate. And then that becomes part of our error rating.
Thank you. There's a question by the column.
Yeah. I have a practical question. To the extent that you need different skill sets to even experiment with some of these methods and data sets, how are you handling that in the federal government in terms of, are you retraining employees? Are you trying to get different people inside the government? And what's that like given the constraints under which you work when, even for those of us outside who can't pay tech salaries, it's difficult to find people?
So that's a great question. I would say right now, the Census Bureau is leading a pilot for data science. So there's a big calling in the federal statistical agencies for data scientists. We've actually put a pilot on the ground in the Census Bureau to really look at what courses, what skill sets, how to bring in and attract data scientists. So I see it as a kind of a two-edged sword. We have to retrain the staff we have to a degree and bring them forward to be part of this evolution that we're doing. But at the same time, when you're trying to attract these data science students coming out of college, we also have to have new projects and things. So the projects I've talked a little bit about, where we're looking at this data, we're bringing these data scientists in where we can. I mean, we're desperately trying to attract them. And not only having them learn our survey cycle process, but really turning them loose in some of these new types of data, alternate data sources, methodology, things of that nature. That's been successful in not only bringing them in, But we have had the struggles with meeting the salaries. I mean, we've lost a couple that we were really hoping to keep. So we are working as a statistical agency with OPM to not only develop the series as a data scientist, but also see what we can do as far as what those pay scales would look like. So that's all being done at the Census Bureau with BEA and others to work with OPM to do that.
So on the BEA side, we take two paths to working on the data science effort. First is we have a core group of really good computational researchers that do the really, really sophisticated modeling work. And then I kind of hammer in the engineering component to it so that it becomes a productionizable piece of art. But then the other side is like raising the human capital level. And so for that, I lead two internal, I call them panels. So that basically we take folks who are just interested and technically capable, and we push them all at the same time through the process of developing a prototype. And so we have one set of prototypes for forecasting, for international, regional, and industry estimates. And so all those folks are in the process of constructing a data set that would be useful for a machine learning-based prediction. And then we have one set of still like 8 teams right now, I think, that are focused on outlier detection. Outlier detection, as we all know, might be a little bit subjective. And so we're trying to get to consensus on this, but through a combination of having each team build, but then share a common code that can be applied across the whole bureau. So we're trying to get this a hands-on experience while building the new flagship products at the same time.
Let me probe a little on this, because there are a lot of people here who are involved in higher education and are trying to produce products who are people who may serve your needs. So what mismatches are you seeing between data science programs and your needs as an agency? What do you have to train the data scientists to do once you get a hold of one?
Well, I would start from the government side, which is we need to train ourselves or train the entire government apparatus to think about data science problems in a practical fashion. There was a long time where data science was a hot topic in government, but a lot of folks didn't actually know what it entailed. And so finding those problems that can lend themselves to a data science solution is actually probably the first thing on the government side. But in terms of the curricula, I'd say training folks so the technical foundations are immensely critical, especially for prediction problems and parameter estimation problems. But being able to ask a question appropriately in a data context is actually surprisingly rare. Like I don't encounter that many people who ask the right question. They will build something and then someone will ask, well, why'd you do that? And they can't answer why. So having the ability to ask that right question is probably what I would want to see more of.
From the census side, I would say from the data science perspective, we've looked a lot at what some of the big challenges are that we're facing. You know, I'll go back to budgets, response rates, those kinds of things. And what we're really looking for is to challenge the existing staff we have to really help us evolve and rotate into how are we going to get to this future state. And in econ specifically, this has been a big push from Nick and from Ron both to get us to think more in this light. So what we've done is really thought about what I would say Jeff's talking about, what are some of the big challenges we have and projects that align themselves very well to the data science environment. So I would say we have about a dozen of those projects, and what we've done is created a curriculum that's really starting to look at the problem solving but also bringing in a little bit of the computer science. So it's really evolving what this person's going to look like and actually putting those things together with the core curriculum. And as they're finishing their assignments in the curriculum and being part of these courses, we've had a lot of like our civic digital fellows who have been extreme computer scientists and presidential fellows helping us guide this process. And so their big tie was helping us identify the projects, the curriculum, and then how to make sure they're successful, but then how do you continue to evolve the organization to support such efforts? And so the other part that I think is a little difficult is as we attract these really sophisticated people coming out of school with the skill sets, is keeping them engaged and really embedding them with the groups that we have now to really move this forward at a lower level, not just coming from the management spectrum down, but really getting it going. And we've seen some success with that. Like just some of the projects, we held a big data day where we brought all of our civic digital fellows and other organizations to Census, and we showed off some of the really cool projects that had been done just over the summer and really got people excited about what the future would look like. And it was amazing the outpouring we had of people who really want to be a part of this.
It's a great way to end. So we don't know how to thank you for joining us at this little university on the hilltop. Thank you very much.
Thank you so much.
I do, okay, great. I'm actually on my tiptoes, so you might have noticed that I'm about 2 inches taller than I was earlier today when I had, and it doesn't seem to be helping, actually. Okay. So I think that was wonderful. I'd like to thank the panelists, and I'd also like to thank those who participated in the conversation. They were really two very different takes on data blending, and I think it's really important to understand all the different ways people are blending pros and cons of these different approaches. So maybe we can give one more round of applause to all of those who helped participate. And of course, these types of events do not occur with only one person doing the work. And so I'd really like to take a moment to thank those who really helped with the planning. I'd like to thank Micheline Chavez for actually making sure this all came together today. I think she was the most instrumental in making sure that the event came together. I'd like to thank Mike Tragot and Amy O'Hara for their support in helping kind of design the event. And of course, I'd like to thank MDI and the McCourt School of Public Policy for funding the event to make sure that we could have a nice reception following the event today. So I hope all of you will stick around, chat with some of the panelists and with the other participants. And tomorrow there is a small group of us that are going to be working on a white paper related to data blending that will eventually become a product that we post at MDI. If you have thoughts that you'd like to share with the panelists and others who will be participating in that, please come and chat with us because we do want to put together a set of best practices that might be useful to a broader community. Thanks a lot for coming and enjoy the reception.